Hello class, welcome back to another section of our intensive multivariable course. In this class, we still continue the vector functions which we've done most of them in our previous classes. For this class, you consider tangent vectors, unit tangent vectors, unit normal vectors, and binormal vectors with some sub-examples. If this is your first time visiting this class, kindly press the subscribe button and don't forget to turn on the notification button. Please watch this video to the end so that I understand every part of the video. So, tangent vectors. From calculus 2, you know that if you differentiate a function, you get a gradient function. So derivative y prime is always a gradient function. But in vector functions, when you differentiate a vector function, you get a tangent vector. You know, a gradient function gives a tangent in that, so if you have the vector function, once you find the derivative, you're going to get the tangent vector. So tangent vector simply means, assuming we have a vector function, say 2t, sine t, e to the power t. So if I find r prime of t, I simply get 2, cos t, e to the power t, and that gives me my tangent vector. Now, unit tangent vector is simply how you find the unit vector in the direction of a particular vector. So you find the vector itself, r prime of t, over the magnitude of r prime of t, and that gives me the unit tangent vector. Let's solve a single example so that you see how we go by tangent vectors and unit tangent vector. So he said, I have a vector function t squared I plus 2 sine t j plus 2 cos t k, and I'm to find the tangent and unit vector of this particular function. How do I do that? First of all, you write a function r of t, don't forget the arrow which indicates the function, is equal to t squared I plus 2 sine t j plus 2 cos t k. So to find my tangent vector is simply equal to r prime of t, which is equal to 2ti plus 2 cos tj minus 2 sine tk. That gives me my tangent vector. And as unit vector note, we're simply going to find the magnitude of this tangent vector. If I find the magnitude of my r prime of t, this would be the square root of 2t all squared plus 2 cos t all squared, then plus negative 2 sine t all squared. What am I getting for this? So the 2t all squared will give me 4t squared plus 4 cos squared t squared, plus 4 cos squared t plus 4 sine squared t. Remember from trigonometric identities that if you have cos squared plus sine squared, you're going to get 1. So this is simply equal to the square root of 4t squared plus 4 multiplying 1, which is equal to 4 root of 4t squared plus 4. Let's leave it here. Now we have our units, our length. So we're going to get the unit tangent vector. Unit tangent vector simply to be equal to my r prime of t over the length, which is 2ti plus 2 cos tj minus 2 sine tk all over the square root of 4t squared plus 4. That is simply how to find the unit tangent vector and tangent vectors. Let's go to the second part. I have the unit normal vectors. When you say unit normal vectors, it's simply denoted by, so unit normal vectors is simply equal to the derivative of the tangent vector. So I'm going to have t prime of t. So now I'm going to differentiate the tangent vector to get t prime of t over the length of the tangent vector. So meaning if you want to find normal vectors is simply the derivative of the tangent vector. But if you want to find unit normal vectors, that is what you have to divide it by its length. So that is normal vectors. Then for the binormal vectors, when you say binormal vectors is simply the cross product of a tangent vector and a normal vector. So if I find a cross product of the normal and the tangent vector, then I get a binormal vector. Now let's see this. And to find the normal vector of this, t 3 sine t, then 3 cos t. So if I find the normal vector of this, I would have to first find my tangent vector. So therefore my tangent vector, I go again to be equal to r prime of rt over the length, this is just tangent vector, so you just differentiate. So this is equal to 1, then 3 sine t will give me 3 cos t, then this will give me negative 3 sine t as my tangent vector. And if I differentiate this back again, then I'll get my normal vector. So if I find, so this is simply t of t, so t prime of t, which is equal to n of t, will be equal to 0, then negative 3 sine t, then here will give me negative 3 cos t. That is my normal vector, So the cross product of my normal vector and my tangent vector will give me the binormal vector. So you simply find a cross product between these two. So that is, if I am to find, I'm going to write my I, J, K. And this part, starting from the T1, 3 cos theta, then this part will be negative 3 sine theta. I draw this. Let me make it sine t. Then I come down to the normal vector parts. I have 0, negative 3 sine t, then negative 3 cos t. So at this point, as usual, if you want to simplify this matrix, you take your I, you close down this part, you are going to get 3 cos t multiplying negative 3 cos t, then minus negative 3 sine t multiplying negative 3 sine t. And only this part is going to give us I open brackets 9 cos squared t plus 9 sine squared t, which is simply equal to 9i. Then when I come to the j part will give me, it will cancel here and cancel the top one. So I'm going to get 1 multiplying negative 3 cos t, then j is minus, so already I'll put minus here. So negative 3 cos t, then I'll come to minus 0 multiplying negative 3 sine t. Then this part alone will give me negative j open bracket negative 3 cos t. Then when I come to the k part, the k part will simply give me the k part will simply give me 1 multiplying the expression negative 3 sine t, then minus 0 multiplying this, so that part will be 0. So I'm going to get 9I minus t, so plus t, 3 cos t, then minus 3 sine t k. And that's the end of this section. Thanks for watching the video. Kindly subscribe, you like, and also share.